Hi everyone and welcome back. Welcome to my YouTube channel, and in this playlist we are talking about Prisma, like how to do the migration, how to create migrations, how to generate migration, how to generate the clients, all these things. So this is the third video, and in the first video we just talked about a simple Node.js app, and we just try to create the users like this simple server.ts file. We just use prisma.user.create. So in this next video, we are going to understand the migrations and the models more, because what we are doing is we are writing a schema.prisma file. We are defining all the different models we need in the project, like user model, course model, student, university, all these different models. Okay, like if we talk about simple blog post application, then the post, comments, users, reviews, all these kind of models we have to define. Those will automatically gets converted into the entity classes, sorry, the database tables, and the client can also be generated for the same. So let's talk about a couple of examples. Let's say I'm going to create a model playlist. Okay, like playlist track, these kind of examples we can talk about. Model playlist, and inside this model we can define all the attributes. Okay, let's say the id is int, and you will see that this is not nothing like JSON. It's a simple schema file and it has its own syntax. Okay, then we have, like, let's say description, which is of type string, and id, like how to define the columns, how to define the primary key. For that you have to make @id, and then the default is auto incremented. You can actually install this plugin which will help you with the syntax, because it's totally different syntax. Like earlier you might have written the TypeORM migrations, TypeORM models or entities, or the SQLized entities, but this is little different. Here we are defining the schema file. So this is auto incremented, description is string. Let's say I have a tracks in the playlist. So I'm going to create another model for that. So this is the playlist track of type array. Okay, that means I need another model, playlist track, and here you will define all the properties for it. Let's say id, and id is again int, default auto incremented. You can just copy and paste. Okay, and then all the other attributes, let's say I have added 8, and this is a timestamp column, so it will be date time. Okay, I also don't know the exact syntax, so I'm just using this plugin and it is helping me a lot. Let's say I have a playlist id. And how can we create the relationships? That's another thing now, because it's not like we are going to have only single table. There can be n number of tables, and there will be relationship like one to one, one to many, many to one, many to many. Okay, here we are going to have the playlist id as a foreign key in the playlist track. So how should we define it? Let's do that. So inside this we have a playlist, and this is pointing to the playlist entity, playlist model, and here we can define the relations. This is the relations and field. Okay, which field you are pointing to? So this field in this entity is referred with, here we can define the references, referred with id of the playlist table. Now our warning goes away, right? If I just remove this, and you see this, and it says that error validation failed, tricks in the model playlist. So it is actually expecting that you are going to define the relationship inside a playlist track. You can see that the correct message, right? Error validating field, the relationship field tracks on the model playlist is missing. Okay, so here we are defining the relationship. So what we are doing here is, the inside this playlist track, it is pointing to the playlist id. I mean, the playlist id is a foreign key in the playlist track, which is referred with the id as a primary key from the playlist model. Okay, now we can create another entity. Let's say model track, and here ID is again auto incremented primary key, and I can have a name which is type string, and here I do have all these three entities, and here also I can have track ID, let's say, which is int. I didn't specify the explicit relationship between this playlist track and the track. The only relationship we have is which is enforcing the integrity constraint, okay, because this can have only the ID of this playlist primary key, playlist table primary key. This is the ID, and we do have playlist ID as a column in the playlist track, which is actually a foreign key having relationship with the primary key of the playlist. Okay, now this is done. How we can do this? We can just use npm run Prisma Migrate. It will check the schema file loaded from the environment variable, and this is our database URL, and it is going to actually run the migration. Will generate the models in our table, and here you can, because I already have some data. Do you want to continue? Yes. So it will just wipe out all the data, and this is asking me the name. Okay, it's, I can say, the initial migration, and then if I change anything, then it will create the new migration, and here you can see migration.sql file has been created, and there we will see what all tables we have. Okay, so we have table playlist, playlist track, and now this is the important part, with what kind of relationship we have, right? So inside playlist track we added a constraint with on the playlist ID column that is referring to the playlist table ID, and this is like a primary key foreign key constraint we have added foreign key. Right now if you change something, you run the migration again, it will automatically generate the new migration. And other commands which you already know, there is a Prisma Generate, and Prisma Generate is also another command which will generate the Prisma client with these entities. Okay, now let's see the another example. Let's say user blog post users, comments, reviews, all these kind of entity we are going to create as another example. Hi everyone, so let's take a look on another example. So I will just you can delete the migration because we are just playing around this. You can remove this schema, and let's create another thing. Here we are going to play a little bit around simple blog post kind of entities. Let's say I'm going to create a first is model user, and that contains the ID which is int @ID, which is auto incremented @default, and default is auto incremented, and I have email which is of string, and I can add the constraint here. You can see, I think it should be unique, and I have a role which is of type role, like if you have some kind of enum, right? So in that case I can add a enum. Maybe there is some kind of a column where you wanted to create enum, so let's say enum role, and it has only two, user and admin. Okay, so now that really works. We have created role, and I have another is, let's say, ID email role. We have a name and this string which is nullable. If you see the question marks, that means that is nullable field. Okay, role name, and we can also have all the posts which you are going to write from the post entity, post model, and profile which you are going to add as another model. Okay, let's say first create a profile. So we are going to create model profile, and inside profile we have couple of things, which is nothing but ID. I mean, it's just like I just wanted to show the relationship. That's why I'm creating another model as a profile apart from user. Here we have a biography about the user and then user, because profile is going to have a foreign key from the user entity. So how should we define this? User is of type user. Okay, it will have a relations, and here we will define the fields. Fields is let's say I'm going to have a user ID. So first of all, you can define that user ID here. User ID is of type int. Okay, so this is user ID column referring to primary key of the user table. Yes, so this is a relationship we have created. Now similarly, I can create a model post. Inside post model, because here you can see the validation error because user is having relationship with the post, but post model is empty. We haven't defined the relationship there. So inside we can have ID as auto incremented. That is first thing, and then we can define all the other like created at, updated at. This is of type date time, and you can also assign the default. Okay, what will be the default value? Default can be now. Now means the current date time. Okay, title is of type string. Published is a boolean. That is boolean, and here you can also set default using annotations. Default false. So this is just like a Prisma schema model syntax, and we just need to follow the syntax how to write it. So I'm going to post. Published is boolean. User is having the relationship with the user. So here we can say this is author, and we have a user ID. Let's say this user ID is integer. Give me a second. So if I just format this with the Prisma, okay, you can see the magic. I mean, when I did command shift P format with Prisma, it automatically adds the columns which I needed. Like in the post, I will need author. Author will have a primary key, foreign key. Author is of type user, which will have a relationship field here as a author ID. Author ID will be of type integer, having a reference with the user entity. Okay, and other relationships like what are the different categories of a particular post. So I can have another entity, let's say categories, and it is pointing to category, which is array. Okay, so you will be defining categories model now. Simple. And this is having, so there will be like a post can have multiple category, and a single category can belong to multiple posts. So here we are talking about many to many kind of relationship. So one to many we have seen, a single user can have multiple posts. For that we have defined this, that author inside the post will be the foreign key. Author ID will be the foreign key inside the post table, and single user can write a multiple post. You can see here. But let's say I'm also having categories. But if I do command shift P, okay, here I will create a model categories. Model as a category, and I will just define primary key, auto incremented, and then maybe the categories like, okay, this blog is about JavaScript, Node.js, React, and all. The name of the category and the posts to which it belongs to. So Now this is a many to many relationship. So here like relations, and we are actually specifying the reference, because in the case of many to many it always creates a new table. And the same relations we can add to the category, because single category will belong to multiple posts and one post can have multiple categories. So you can see the relations references, and we already have an enum. Why it is not liking this? Okay, let's see. Parsing attribute relations on the fields. So here what we are doing is profile. Do we need this? Inside user we have profile, or we can mark it as an optional nullable field. Okay, so now we have all these categories, all these models defined. What will happen if we just run the migration? We should see all these tables created, I think, with all these relationships. So let's do npm run Prisma Migrate. So it will just check your database is running, and if that database is running, then it will just open that up. It will run the migration. So we need to give the connection name. Before that, I wanted to open our database. This is our database URL. I'm just trying to connect to the database, and then we will see the table structure and all if there is any. So this was our earlier database, and what I'm going to do is enter the name of new migration, which is, let's say, the users. Okay, it is synchronizing with your schema, and we will check our database now. And you can see we have all the new tables, the categories, the post, and category to the post. You can see this is many to many. Here you can see the category, the post, the profile has a user ID, which is the foreign key, and the user, which has a unique on the email and the primary key. Okay, so this is just about how we are running the migration. We will talk about one more example, and then we are good. Like we can actually do some real project where we can define these kind of Prisma models. We run the migration, generate the Prisma client, and do the actual APIs, like some kind of a blog application, some kind of actual real world application where you are doing insert, update, delete, find, running the queries against the Prisma client. So let's take a look on a little bit more complex example. Like I do have only two entities, users and the bank accounts. Okay, so I do have users, user entity, which is ID primary key, email is unique. I mean, we can also explore the couple of other options, like how to write all these things at the rate unique. And you can also pass, I think, some parameters to which particular. So this is a constraint name here, users dot unique emails. This is a constraint name. You are just specifying. Role is still fine, name we have, and here I'm going to associate this with the bank accounts, and I'm going to create another model bank account. Okay, other than that, I mean, I always use snack case for specifying the namings. So you can just follow the same, or you can follow one particular approach. Created date is date time, updated at is also again date time, and the default, you can specify default is now. Same with the updated at, I think there should be something like at the rate of, no, that's it. There is there something like updated at. So whenever you update it, automatically it will populate that. Both are date time. Now you can also, let's say I'm defining this model, but I don't want it to use this particular table name. Here you can see all the table names are in the camel case, and you can also see same with the columns. You can specify the column names whatever you want, created underscore in the snack case, and here I can do the mapping. How can I do? So I think there is a map, and map will actually associate the naming conventions whatever we can follow. Okay, I wanted to map it with the users, or let's say more specifically account users, because users table I think we already have account users. Okay, now we can create another model. So here with this at the rate map, we can do a lot of things like specifying the mapping of the entity, like what will be the name of the table here, that is the objective. Bank account, this is another model I'm creating. ID is auto incremented primary key, so I will remove everything here. The first thing we have is the account ID, and account ID is of type string, and this is ID, and the default is, here we are going to have a UUID. So I think there is a type UUID also there, same as auto incremented integer. We have a user underscore ID which is string, and here we are going to have a relationship with the user. User is of type user, and here we will define our relation with which field. So here, okay, I have a fields is user underscore ID. User underscore ID is a string. Okay, we can also set because this is a string, so we can set this is a UUID. Default is UUID. Okay, this is integer, so let's make it as a string also. We don't need auto incremented primary key. Now string neither is a built. Okay, S is capital. Now this is field is user ID, and we have references. This referenced with the user ID. This referenced with ID, I mean the primary key of the user table. And here you can also specify the on delete cascade option. I think on delete and on update. So on delete it should be cascade, and on update you can specify, I think, on delete cascade, and on update is, can we do this? If I specify on update, okay, yeah, I see all these options. Set null I wanted to do, and on delete cascade. That's it. So we added these actions. What will happen if the primary key is deleted, right? So we have a user, then I have a number int, and you can also specify the default values of any particular column. Let's say I wanted to initialize it with 1, that is an integer, and created at and updated at, these columns you can put on most of all these models, because these are the life cycle models. Keep track on your entity record creations and all. And here I can add the unique key constraint, because here you can see I can specify map index on what all columns you wanted to add an index, unique key constraint you wanted to add. So here I am adding that on the user ID and the number column. Okay, and I'm just going to map this constraint with some particular name, which is, let's say, the bank account dot user ID number unique. This is kind of constraint name I put, and then again last is just add the map. I'm just mapping it with the bank user bank accounts. There can be a better naming for the tables. Yes, now we can just run it. I can just format this if anything is left. Okay, everything looks correct. Then we can just, what we can do, npm run Prisma Migrate, and it should be able to create the account users table and the constraint with these particular names which we have specified. Okay, so this is all about migration, how we are defining the relationships, creating the migrations, and populating things in the database. All different types: string, enum, number, date, time, how to define the primary key, foreign key relationships, okay, how to define the unique key constraint. Okay, let's see the real application in the next video, guys. Stay tuned. So now we are going to, let's say, build a simple authentication system, and here we are going to do all the Prisma related APIs from the Node.js. Okay, let's see the migrations we have created, and this is the table structure. We have only two tables, so the previous tables have been dropped because we did the schema override. I mean, we just removed the previous example, created a new example here, and did the migrate run. So what will happen? It will say, okay, now you have only two entities. It will drop the rest of the entities. So you can see on the top, we have actually dropped all these things because we actually cleaned up the schema file. This will obviously happens. Okay, you define the 5 models, and in the second go you didn't change the you didn't update the models, you removed the 5 models and introduced two new models. What will happen? All the 5 tables will be dropped because it's like incremental migration is getting created. So you can see all these are dropped, and this has created these two tables with all the relationships which I have added. Now let's say if I'm creating just I'm even again going to remove these. So what will happen? Let's say I just take the backup of this, and what we'll do is I will just create two another, and this time it is a simple author. Okay, author is the model, ID primary key, name is fine. I will just have a name which is of type string, and this is author, so I can have a simple relationship. Here I have a quotes, and I do have another model as a quote, and this can be author, and I do have another model this. So this is going to have like, okay, author ID is going to be of type string, and I'm going to define the relationship one to many because single author can publish multiple quotes. So it will be author, and we will define all the relations fields first. So the field is author ID in this table, and the reference to the ID of the author table, and unique key we don't need this relationship, this constraint, unique key constraint. Now I just created these two another entities, you can see. Okay, here it can be the constraint name can be a different one, but it's like there are two new models I have added. Now what will happen when I just run the migration? It is going to wipe out all the existing tables. Npm run Prisma Gnerate. It will ask me the name. Okay, this is the new migration it will generate, and then it will actually remove the existing tables we have and just keep these two only. Currently Prisma supports only one single schema.prisma file where you have to define all these things, all the models. So I'm creating another migration with the name of authors, and you can see this here, and based on the changes it will do that, and you can see it has dropped the account users and user bank accounts. Now we have actually two new entities, two new models: create new table quotes, create new table author. So this is how it works. You reload this, the existing tables are gone, and you have these two new tables. Okay, so this is all about just playing with the Prisma migration, how it works. And the Prisma Generate, you can actually now generate the clients for these two models, and then just play around with the different methods provided by Prisma client APIs to find all, remove, update, delete the data inside the tables.